I work for Ernst & Young. I'll be moderating today, although we are doing more of a presentation style. So Carl and Igor are going to take you through a presentation, then we'll have a good slot at the end for questions. Just on the questions, if you do have a question as we go through, if something pops into your head, just put it through on the chat. I'll take a note and we'll try and get through as many as we can at the end. So just introducing our speakers, we've got Igor Starkov, he's CEO of EcoDomus, and also Carl Ericson, CEO of Augmented Construction. So we'll just move on. Carl, we'll take a look at the agenda. So the agenda today, I'm not going to read out every item here, but basically how this is going to work, Carl will take you through some BIM applications for the design and construction phase of the life cycle before moving on to Igor, who's got some great examples and information about the operations side of using a digital twin. So I don't want to talk anymore, but just before we start, we just want to have a little bit of a question, get people engaged, do some polls. So Marissa, if we could just pop up the first question. So first question, in terms of your experience of BIM and digital twin, how would you gauge your experience? Is it no experience? Is it a minor experience? Maybe moderate or intermediate, you have some experience, but you wouldn't consider yourself an expert, or would you say you're very experienced, maybe it's your day job? If you select one of those and click submit, we'll have about 30 seconds. No right or wrong answer, obviously, we're just trying to understand the makeup of the audience. Okay, good. So we've got a good mix. That's great. So there's something for everyone. That's great. Yeah, no, that's good. Thank you. Okay, and then we've got another question. So this question is going to be related to kind of what's your role in the industry. Sorry if we've missed some roles there, but are you an end user owner? Are you more on the design side, architecture, MEP, that kind of thing? Are you a contractor, GC? Are you a broker, or do you work more as a consultant, owner's rep, that kind of area? And apologize if I missed anyone's role in that one. Again, just to try and gauge the makeup of the audience. Okay, interesting. So again, a good mix, people from different parts of the industry. A lot of consultants, owners, reps. Okay, interesting. Okay, without any further ado, I'll hand over to Carl and enjoy the presentation.
All right, thank you very much, Matt. All right, I'll move on to the next slide. So hi, I'm Carl Ericson with Augmented Construction. I'm a construction veteran, having worn many different hats over my career, from construction manager to owner's rep to actually now VDC consultant, right? And ultimately, Augmented Construction was founded to bring this new technology to light. And today, really what we're going to go through is this driving concept of what a digital twin is. And a digital twin means a lot of different things to a lot of different people, but we really want to give everybody a little sneak peek into what our digital toolbox looks like. On some level, you could almost think of what we do, Augmented Construction, as a systems integrator, consultant that happen to have design and construction experience so that we know how to use the tools. And then we're going to be listening to Igor tell us about his fabulous platform, which is really about the how to house the data and interact with the data for the future life cycle of the construction, and that's EcoDomus is the platform. So I'd say that EcoDomus is the end state of your ability to interact with digital twin. Leading up to that, right, there's a lot of different stakeholders, and digital twins mean a lot of different things to a lot of different people. And at the end of the day, we're just going to touch on that through this presentation. All right, so moving on. Everybody has to have the obligatory look at this. We have real clients and we work with lots of different people. We don't have to spend a lot of time on that. I'm going to be focused, if you look at the bottom right-hand corner, I'm going to be focused on that little blue circle, the delivery phase, right? How do we use the digital twin during the design and construction? And then how does that interact with, you can see the white box where EcoDomus is listed, right? That's the life cycle, the operational phase of the real estate asset. But conceptually speaking, right, you can see on the screen here, digital twin is made up of a lot of different things, right? During the first phases, what we're going to be talking mostly about is BIM, building information modeling, because that's really the start for a ground up, from a ground up perspective. It's been around, right? BIM isn't new. The concept of digital twin isn't new. It seems to be pretty hot these days. I think really a lot of this has to do with the fundamental shift that's required to do it well and to do it easily. So it's obviously change is hard, right? As it relates to how do we create these digital twins? How do we interact with the digital twin? How do we know what we're going to do with it, right? What is the end state of it? So, you know, one of the things that we push on our clients and then the industry is that you really can't wait for the construction manager to show up to the plate to start caring about what your BIM process is going to look like, right? You almost can't even, you know, start from the architect's perspective, right? The owner, right, really should know what is their end state. I know that's a little bit of a circular logic, but ultimately that's the challenge to be able to do it well, is to be able to manage the expectation. And what is the goal of any of this, right? It's very, very easy to spend too much time and effort on any kind of technology, right? Understanding the end goal is ultimately one of the most important pieces of filling in the I in BIM, which is information along the way. So why do we struggle with it? Well, we struggle because, you know, not everybody understands what they want to get out of it. A lot of different, especially in larger scale projects, we can work with lots of different consultants that have different methodologies, different software packages, different means of saving the data. You know, the goals are not necessarily well defined, right? So there are solutions to a lot of this, which is fabulous, right? We're living in a pretty transformational time within the industry with the advent of a lot of different technology that really will help us get that end goal of that ROI, right? Because why do any of this, right? We're doing it because we think it's going to make our life easier. We're going to save money, run properties, build properties, run properties more efficiently. So I'm going to start with this very simple concept, which leads back to building information modeling. And you'll hear this term thrown about very often with designers and architects. And LOD, what does that stand for? LOD stands for either level of design, level of detail, level of development. Different folks actually use different words there. Even on the GSA's website, who's on, in some ways, the cutting edge of their integration. And we'll hear about a great case study with the GSA with Igor, because they are customers of EcoDomus. And, you know, I just want to walk you through, you know, what this is, right? It's a little glimpse into, you know, some of the details here, right? Starting with LOD 100, that is the same thing as your schematic design, right? Pre-design. Moving into or design development. LOD 200, schematic design. LOD 300, design development. You know, whether you use LOD 300, LOD 350, you know, 6 in one and half dozen the other, right? There are a lot of definitions. Really, what's the most important thing is that, and what I've shown on the right hand of the screen, is that if you have an important use case for your BIM, because it's super easy to over BIM, the things that people care about, stakeholders care about it during the different phases of the project, you know, from design, development, design, construction documentation, to construction itself, shop drawings, commissioning, and life cycle, the different stakeholders care about different information at different times. So the way that this is managed currently, the way that we manage it, right, to give you a little sneak peek again into our digital toolbox, we use a platform called Plannerly. It's a cloud-based tool that allows, and this is a screenshot of that on the right-hand side, to the extent that it makes sense visually to understand how detailed something is getting, and you know, how should it be modeled by the folks who are authoring, because a lot of people have their hand in the model authoring during the process, whether it be the architect, specialty consultants, construction manager, subcontractors, and then ultimately there could even be a turnover of a reality capture and FF&E that could be loaded into a model towards the end of a project. It's really just important to understand like who's doing it, right? You just need to understand like what are we trying to get out of it, right? What assets do we care about? What information about that asset do we care about? How is it, right? How, who, where, when, all the different things that we were talking about, right? At the end of the day, great, and part of the reason why we paired up with EcoDomus for this presentation, right, is that their platform is really a great end state. Most people in the industry in New York are very commonly using Autodesk products for the authoring component. I will say though that an important nuance to highlight is not Revit is not a great platform for designing. And when you get into that nuance, you kind of understand a lot of different design firms use other platforms or other softwares for the design phases. Sometimes that could look like Revit. Sometimes that looks like SketchUp. Excuse me, I misspoke. Rhino was what I meant to say. Sometimes looks like SketchUp. And ultimately the transition to Revit happens when you're ready to do more construction documentation. And then from there, right, there's another suite of software platforms that get used by the different construction stakeholders. And that's where we start to get into some of the really interesting field tech, which we'll talk about ever so shortly. So I covered this already, this concept of, well, how do we manage all this, right? We've got all this information, we've got all these different players, different stakeholders, who has to model it, who has to put the information in, when does the information get inserted into our database, which really, in some ways, you can think of a building information model as a big database that happens to have visual information attached to it. We use I mentioned it already, but I'll say it again, we use a platform called Plannerly. There are a couple other options out there. It's just a great way to kind of keep the whole team's head screwed on straight and marching to the same band. What is very critical here, though, is that these expectations are set with the design team at the beginning of the project. Because I will say that if you just are proposing an RFP and you want a BIM project, telling your architect or your engineer or your mechanical engineer, your structural engineer, foundation, geotech, right, the whole volleyball team of people required to build a building, saying as an owner that you want BIM is not enough, right? Again, it sounds like I'm a broken record a little bit, but I am. In order to do it successfully, right, you have to be educated in understanding the final use case, and then be able to create, whether you do it with a consultant like us or, do it in-house, but you need to be able to create a BIM execution plan to be able to manage expectations and to scope out the project. Now, once you get into a project, what we're looking at here, this is another digital tool that we like to use. This is a combination of Navisworks on the right-hand side and a plugin that we like called BIM Track. And what a great use case of digital twin during the design phase is a path to scope certainty, right? Why do we use BIM during design? Why, this concept of what does a digital twin mean during design? Well, digital twin in design is to attempt to get our construction documents to look as closely as possible to what is actually going to get built. And building information modeling is a great way to get there. It's also a great way to review the design, right? And this is a platform that we use, and we've had a great deal of success integrating multifunctional design teams, international design teams, especially in these COVID days where it's pretty tough to get people together. This is what we typically use. This looks like normal QA/QC of a drawing set. Another digital twin application here, right? And in terms of what happens when you're not building ground up, right? What happens when you're doing a renovation? Digital twin still has applications here, right? And this looks like either traditional laser scanning. There's a new flavor of traditional tripod-based laser scanning called SLAM that actually allows people to use laser scanning while they're walking around a space. Navis is a really great platform for that. It looks like a little bit of an exoskeleton, but it allows very, very quick data input. And photogrammetry is something that that we've been very excited about. That's the concept of creating digital twin of an existing condition using 360-degree cameras and a lot of cloud-based data processing. We are very familiar and big fans of open space. Another one we've used recently on a project is Reconstruct, right? Again, the idea of how do we create our digital twin? Well, there's a component of reality capture associated with that. Now, what you're looking at here is we're moving into construction, right? We've used our BIM during design to do QA/QC to get to scope certainty. Now we're in construction and we want to use our digital twin to get us QA/QC to make sure that we really know what has been built in order to get to that end state of the as-built condition, right? A model that can be used very effectively for the life cycle side of BIM. You can use, what we're looking at here is a screenshot of open space, right? Which creates what looks like a Google Street View of your job site. And what we're looking on the right-hand side of that motion there, that's the BIM model. So I think you can see how easy it is to compare planned versus actual. Another interesting use case, although certainly much more on the bleeding edge than I'd say, it does not have any large-scale market adoption, but because of hardware limitations. But augmented reality is another future state in terms of digital twin, right? Again, you can use, if you have a model, right? Again, that's the information. Augmented reality is just a different way to display that information. There's a couple of different tools on the market. I'm sure people have heard the big buzz around the HoloLens 2 and the government just buying a few $1 billion with them, but because they actually work pretty well. The demo you just saw was actually done with an iPad. Again, the Apple has released some pretty great tools to be able to use augmented reality on their phone. I will caution everybody, the state of that tech is really the visualization. There are a number of technical challenges which haven't been resolved to allow for dimensional precision with augmented reality on an iPhone, but visualization is fabulous. Just going to run through a couple of project examples. This is an example where we used open space. That was the 3D 360-degree camera photogrammetry to help with project management and status tracking of a real project, right? So this project was happening during COVID, and we had a very challenging mixture of an owner based in North Carolina and a design team that was kind of scattered through the wind in New England. And this process of creating these digital twins of the project site allowed for the team to come together and effectively manage and keep the project moving through COVID, which was a great use case, and also ultimately allowed for a higher level of QA/QC throughout the process. Another great use case of digital twin during design and construction, we helped work on an ODA design building, which had a very complicated UHPC facade. And ultimately, it was the application of creation of, I'd say, shop drawing level building information modeling that allowed for the type of quantity takeoffs and decision making to create a budget, right? We were in a position where we had a custom facade. The bidders, the people who knew how to make these things, didn't know how to quantify it because they couldn't get just enough detail out of the design. This was just an example of using that tool, that concept of digital twin, to achieve scope certainty during that design and construction phase. Another quick example of that project that entailed a demolition of an existing building, and there was an existing foundation all embedded into bedrock. So this is a Manhattan project, and demolition of bedrock is very expensive, or excavation, I should say. So it was very important to be able to understand the complex geometry of the existing basement and how that overlaid with the geotech report and then overlaid with the building's new foundation. So this is just a practical example of digital twin during the design and construction phase. In this particular instance, it was figuring out exactly how much rock did we have to break, because it was actually moving the needle on budget for that project. I do want to point out here, I'm getting to the end, another thing that's important, and I'd like to make sure that everybody hears, is that, you know, digital twin technology, digital twin tools are not reserved just for mega projects. You don't need to be building a brand new stadium to have these tools available for you and your projects. A recent assignment for augmented construction was the digital twin capture of a 300,000 square foot low-income housing portfolio in Newark. Now, one might normally think, well, I don't get to use these kind of tools on a low-income housing project. Well, the reality is we were able to use 3 different kinds of input technology, right? Traditional laser scanning and 2 different kinds of photogrammetry using 360-degree cameras actually allowed us to do the project faster than a traditional as-built survey would look like, and more thoroughly, because it allowed our client to have that Google Street View viewpoint of an occupied building. So as you can imagine, gaining access into the individual units on multiple occasions would be a disaster. And I'm sure everybody on this call has had that problem where you take 1 million site photos on your iPhone, you get back to the office, and the one thing that you really wanted to look at was just out of screen, or you didn't take a picture of. So example of digitization or digital twin technology applied to an existing condition project. This is a tower that's currently being built in Midtown. Digital twin was used very heavily during the BIM process, during the design and coordination, in order to achieve a more scope certain set of construction documents. And this particular client, we were able to show them a white paper that we'd save them roughly $4 million in design coordination hits after the team had gotten to 100% CDs. And that was purely by the use of 3D building information modeling to find complex design challenges that just weren't captured with traditional 2D floor plans. So this again is the use case of getting to scope certainty is really what's key here. Next thing I'm going to show you is another interesting example of digital twin, again, moving into that construction realm. We were able to use open space here to visualize a project that hasn't been built yet, right? We did a walkthrough on the left-hand side of a streetscape, right? And on the right-hand side, you're actually seeing the proposed new construction in that same streetscape. And I'm going to play a little video here. What we're looking at is the digital twin of the construction site, right? That doesn't sound like that would be all that sexy, but at the end of the day, you know, a picture's worth 1,000 words. In this particular project, there were a lot of governing authorities that had to understand, how are we impacting pedestrian traffic? How are we impacting vehicular traffic? Where is all this construction material coming from? Where is it going? Where are these sidewalk closures? And at the end of the day, this video that you see on the right is a digital twin that we created of the actual site logistics associated with that project in order to get everybody on the same page. All right, so with that, I'm going to hand it over to Igor with EcoDomus and let him talk to you about his platform and the rest of what you do with software during the life cycle. Thank you.
Thank you, Carl. Hello, everyone. My name is Igor Starkov. I'm co-founder and CEO of EcoDomus. We are 11 years old. We've been the first company that took BIM beyond clash detection. And we started working with the facility owners, such as University of Southern California, GSA, and today I'll present a few case studies, including some New York-based clients of ours like Javits Center. We've been working with the leading facility owners and contractors and architects, engineers. We cover the whole life cycle. So it's not just EcoDomus exists at the end of the workflow. In order to build a proper digital twin, which have you seen this slide before, you need to have a process that starts in their design, that go through the construction and go through the handover, because otherwise garbage in, garbage out, right? So if somebody says, well, I have a BIM file, please create a digital twin out of it, the chances are that BIM file was not created to be usable. And so it will require a significant modification to be used for a real digital twin. Our definition, again, digital twin is a combination of technologies that provide you with the ability to answer the question how this structure is supposed to work, which is what you model in the authoring applications, and how it actually works, which is what your sensors and different devices provide you with, right? And our goal is to build that whole environment where we integrate those technologies and where we allow to collect that data. As an example, I will use a building that a lot of people know, Sydney Opera House, one of our clients. So what you see is the regular browser within Ekadamus where I'm looking for some information. Let's say I'm looking for space G534A, which is found within my model. It's underground service corridor. And I can ask any question and get any answer, all the answers about that location. So I can see all of the objects located within that space. I can see the attributes extracted from the Revit file. I can see all of the documents linked to that location. I can see all of the issues associated with it from design through construction into operations. I can see the current temperature, how many people are inside there, what's the air quality, et cetera, et cetera. So that's the complete set of answers about whatever I want to find out. What kind of carpet is on the floor, what's the total square footage of that space. But right now, let's say I'm more concerned about this specific lighting fixture. So I can click on it, I can see this exact information about this specific lighting fixture. Who's the manufacturer, what kind of a lamp type, do we have any documents associated with that lighting fixture? Let's say we have the 60-year-old drawing that was PDF'd and attached to this specific lighting fixture, right, from the mid-60s. I can also see on the box next to it that there's some item is happening, something is going on. So there's an open issue associated with this box. And there's one open issue. I see there's a broken handle, right? So it gives you an ability to create those kind of issues right here within this virtual environment. You can drive around within the 3D to understand what's happening there, right? So we can go through this service entrance. We can go down one level to the machine room or go behind the circuit. Actually, we are on the stage right now within the Sydney Opera House, and I noticed that my layer with chairs is missing, so I can turn it on. So this is the federated model that contains all of those BIM files as the common federated model. This is just an example of some of the things I can do with it, right? Why people do that? What was the goal? Every client has its own purpose or use case, and that's how the digital twin is created. There is no universal twin, right? Every twin performs some function. So for some people, it's, oh, I want to take care of my potential plumbing leaks just in case something bad happens. I want to find the shut-off valve. Others are saying, oh, we do this, the plant utilities turned on and turned off. So how do I do that, right? So based on the operational requirements or operational information requirements, you develop the asset requirements, which are used to create the actual BIM, right? So so it's driven primarily by the ultimate benefactors, and it can be not only the owner. Sometimes the contractors saying, look, we are getting those bad files from the designers, architects that we cannot use. So they can establish their requirements and check the quality of the design deliverables to them before they start working and submitting it to the owner for the handover. So our goal in this regards is to check the model data at all of the stages, during the design, during construction, handing over to operation and maintenance. And then let's not forget that it's not the end of the line, right? So the new design and new renovations happen based on the existing information. So we also need to check what is information that goes from the O&M team to the design and renovation team, and the cycle repeats itself. So you can use BIM not just for 3D visualization, you can also use it for providing the analytics like what Carl was showing you earlier. So we can generate those reports within the application. You know, what kind of assets do I have? Let's say, show me all of the VAV boxes that cost more than $200. And you immediately get that file in Excel or some other format, or show me all of the objects that have been installed and commissioned in January. All of that is driven by metadata, and you can get all of those reports. You can see them also in 3D. You can run this and say, show me those VAV boxes, and you get those VAV boxes highlighted, and you can investigate each individual object right here. Show me that VAV box, what are the properties, et cetera, right? Let's not forget also that documents are a part of the information model. When we talk about digital twins, we usually assume that they are created by packages like Revit, Graphisoft ArchiCAD, or Bentley, but there's a lot, that's structured data set. But there's also documentation which is unstructured most of the time, right? Photos, diagrams, schemas of some sort. So they, floor plan drawings. So you can attach them to your BIM objects quite flexibly. In this case, you can quickly pull them up, like in my example of the Opera House. When I clicked on the lighting fixture, I immediately found all of the interrelated documents. So assigning documentation to the BIM elements can be done in a new sophisticated way. So you can continue to work with your PDFs, with your DWGs, create your markups, etc. And at the same time, you can assign them properly to the BIM elements, and it becomes your continuous transition from the old 2D way to the new BIM-driven way, right? And the processes also need to be automated based on the BIM. Like in the past, if you remember, 10, 15 years ago, we had this new revolution of tablet PC based in issues management, right? So packages like BIM 360 Field, which used to be called Vela, or Latista, which I was co-founder of as well, which is now part of Oracle, right? So these issues management systems now can be also linked to the BIM objects and be also quickly filtered and managed. So it's not just creating a list of disconnected issues. They are all associated with the BIM elements. Like here, for example, if I found that this fan has some issues, I create an issue for that specific object. This object is automatically associated with an issue. So we don't have to search for what element is affected. I can immediately create the markups. Like in the BIM track that Carl was showing earlier, we can track all of those issues and associate these issues with the object and exchange them using the open file format called BCF. It's a BIM collaboration format. So we can track those issues. We see the history of the changes. So this way you are operating, you don't have even to open all the time the 3D model. You can see the associated screenshots with that. So you can affect the work in a BIM-driven way, or continue to work in your traditional way with 2D documents. In terms of the integrations, like I mentioned, digital twin is not just one BIM file or not just one point cloud. It's a combination of all of different technologies. Siemens, Honeywell, Schneider Electric provide some data from the sensors. Maximo or Accruent store information about the maintenance activities. If you have a lot of distributed assets, you use a GIS, most probably Esri GIS. You have documents. So we established the way how those systems can exchange information between themselves to avoid the potential problems. Like what happens often is large owners, they have several systems where they track spatial information. Like I was at one of the New York universities, and he says, look at my building automation system. It shows that room 502 has the temperature is too high. But he said, but we don't have room 502. If you look at my space management system, there is no room like that, because all of these systems in the past were populated separately in a different manner. So right now, using a BIM-driven approach, you have the central common data environment where all of the systems can get the same quality of data. So the same assets can be tracked across multiple systems. Like let's say within Maximo, you replace a fan coil unit 27. In the past, nobody knew, only the guys who manage Maximo knew. Right now, we can notify the energy team so they would know that they need to change their operating schedules because their fan coil unit is not there anymore. We can also notify the real estate team because they will warn the people who are sitting in the room served by that fan coil unit. right? We can also notify the BIM guys who would update the model to remove that fan coil unit from the model, right? So all of these interactions and notifications happen because the system becomes the accurate representation of what's happening in real time. Here's the sample of the project we did with Melbourne Water, which is the city utility, water utility. They used our API to build this. In this example, as you see, this is the industrial facility, which has the pumps, and pumps have information associated with it, information extracted from the model, right, from Revit files or from Bentley files, but these guys also connected it to Maximo, like you see here. So this information has been exchanged with Maximo. OSI Pi server, which is the SCADA system that tracks the data points from the sensors, and Inflow is the document management system. So all of these three integrations were done using EcoDomus API. So when they investigate each individual object, they can run these kind of reports, show me all of these change, how this object worked from March 16th to 17th. And you can see all of the time series data for this specific object. You can see all of the documents. You can see the work orders that were coming in from Maximo for this object. You can create new work orders from here, etc. So all of these systems talk to each other, right? For the distributed assets, like I mentioned earlier, with GIS, you have the ability to place those objects over the map and jump from each of these objects from the GIS domain into the BIM domain. Like in this example of our work with New Zealand Auckland Metro, where they have multiple new stations and tunnels. Here's a sample. I selected this station, Aotea station, and jumped from here into my BIM view. And within the BIM, like you see here, it's augmented the BIM file itself, which is a combination of dozens of IFC files. It's placed in the context of the point cloud, which was created using the aerial drone scanning, right? So all of the coordinates aligned, and so you can see, like in the Carl's previous example, how it's supposed to be. So they are still in early construction. They're working on the piling right now, but they already can understand how it's going to work. So they can simulate all the the people movement and the sensors movements. All of that can be visible before they actually finish construction. And at the time of this construction, they collect all of the necessary information. For each pile, they actually attach about 8 or 9 different documents. So the level of granularity that they collect there is huge. Well, because it's a very sensitive project, right? It's a public open facility, and they need to collect as much data as possible. Here's the sample of the 3D GIS, which is a combination of BIM objects, where some of them are not detailed. You see, they're only white shapes that we know only total square footage. Some of them, we have the full LOD 500 BIM. In this case, I can fly in here, select, let's say, this lighting fixture, and say, show me where's the shut off, where's the circuit breaker for this specific lamp. And since it's modeled correctly, I can trace the electrical system, and I can understand that it's on the circuit 5, and this is the panel board. So that's where I need to go, and the electrical panel board, and I saw what room it is in and which specific circuit I need to turn on and off. So you see, we jumped from the bird eye view down to individual asset view. And a lot of people right now on mobile, so we obviously support mobility and data collection on iPads and Android tablets and phones, smartphones. Using QR codes or barcodes, you can immediately find an object within your model viewer and see associated documents, fill out electronic forms, create and fill out inspections. We even can do this using the editable PDF file form. So that means that you pretty much use the same paper that you used in the traditional paper way. You can create electronic PDF file and edit it inside of this iPad application. On the SCADA side, on the sensor side, the goal really is not just to show what's happening, but be able to compare how it's supposed to work. Remember, like I mentioned earlier, this is what the power of your simulation provides you with. You can calculate how the systems are supposed to operate under the conditions, right? And the sensors will actually tell you whether you are within the acceptable range or not for the same object. And you can also visualize this information, like in this example, where the BIM model was augmented with these panels that show you real-time data. You see these blue panels, they show you the real-time sensors values. And if the values are outside of the range, it makes the object red, it makes them blink or not blink. So these are the opportunities that you can employ for visualizing your performance, your building performance better than just the traditional way of looking at the traditional SCADA devices. Because within the SCADA interface like Siemens or Honeywell, yes, you can see these static JPEG images, but within the full BIM, you can immediately click on any element and understand what this valve shuts off, what the directions of the fluids in here. So it's way more sophisticated way of looking at the asset data and the performance data. And as additional ways of using the IoT devices, you can also connect to the presence sensors, like we used a couple of them, like point grab and density, the others that show you the number of people in specific area. And because we receive the number of people from them, we can highlight the sections of the building. Let's say it shows you the conference room, whether if it's in red, it may be over capacity, or if it's green, it's under capacity. And in this case, you see the janitor just passed by here. So we show it's only one person, it's in green. And the video camera shows you real-time feed here. So in this case, the BIM was used to train the first responders, the firefighters and police. They didn't need all of the pipes and ducts. So the model of the stadium was created in about a week. So it was mostly architectural model of the stadium, but that served that specific purpose. You see, so it doesn't have to be always every single element. It depends on what the purpose is that the client selected. Point clouds, like I showed you earlier, the train station, the point cloud can be also used within the facility. Like in this case, you see it's augmented. The BIM is core and shell BIM, but the pipes and ducts are laser scanned and placed in here. So the chiller, we see half of chiller is the object and the rest of it is the point cloud. So you can visualize in pretty high level of detail everything, and you can measure the distances between the pipes and the floors, etc. At the same time, some of the objects have been modeled, so you can see their data. Let's say chiller 1, I see what's the model number, etc. Manufacturer. It's kind of in between version between the complete point cloud that doesn't give you any parametric data and the full LOD 500 BIM that has everything, but it takes longer, way longer to create a decent model for the full BIM. So now let's look at this case study, which is building that all of you in New York know quite well. It's a Javits Convention Center. This model was created in the course of about 1 year by creating Revit files from the PDF drawings. So the client didn't have anything except for PDF drawings, and our modelers created this. We connected the created model with the several systems that they have in use, Procore for construction project management, Siemens for BMS and SCADA, and eMate for work orders. Right, so these were, and we also did the QR coding, barcoding of the equipment. So they use it to verify the accuracy of their asset register, because the asset register in most organizations is just a long list of values, right? If something is deleted or not deleted, you may never know. When you see actually all of these electrical panels and variable speed drives, and you have the QR code on it, and you can scan it and verify it, that gives you a much more certainty that you actually have what you think you have. Right. By the way, the Revit file that we've generated has been used by U.S. Army Corps of Engineers when they developed a hospital inside for the COVID vaccinations. So they liked it a lot because it was much faster to plan all of the necessary, hospital cubicles inside. So that was the work with Javits. This is just an example of the BIS data for some of the assets here that shows you the information associated. This is the basement. This is how you can create the work orders like I showed you earlier.
Mhm.
And the next case study is US Government General Services Administration, GSA, the largest landlord in the world, 9,000 buildings, you all know them. We worked with them several times, about 4 or 5 projects over the 10 years. Last fall, we were selected as the essential common data environment for the GSA. The project specifically that I'm showing you today was one of the pilots and in Philadelphia, GSA Camden Courthouse, which shows what they used in the before they used paper, and what we did is we gave them the iPads. So all of the drawings were PDF'd and they were linked to the objects. AECOM created a BIM model, so that the Revit BIM model was loaded into EcoDomus. And what we also did is we connected to BAS, Automated Logic. And what we also did, that was quite unique, that never repeated since then. We used the predictive energy model generated using the Energy Plus that was compared with the actual sensor data. So we could trace down to individual VAV box whether it works close within the range of acceptable values or not. But that was considered way too difficult for the industry right now. Even since then, we haven't had many other projects like that. But that was, I think, it will be coming maybe in 5 to 10 years from now, as the standard way of managing the energy is simulating it and then comparing to the actuals. But what these guys found very useful, the technicians, is utilization of iPads with the tracing the pipes, tracing the electrical system, tracing, having all of the documentation instead of having all of this in paper, having it all on an iPad and seeing it all in 3D. So that's kind of one of the reasons why GSA has been using BIM is for managing all of their work. They're creating more and more BIMs for all of their buildings. Obviously, not 9,000 of them have BIMs, maybe 5%. But it's definitely a goal for all of the owners we talk to is to create models for the whole portfolios of their assets. So that's us. There are more books written about EcoDomus case studies that you can read. Contact me and Carl, and I think we can pass back to Matt and others to have maybe some questions answered.
Yep. Thanks, Igor. Thanks, Carl. That was great. So yeah, we've got a few questions through. So let's start there. I think the first question I think you answered it very specifically was around, do you integrate with Maximo or other work order systems? I think you answered that, Igor, but I don't know if you want to add any kind of flavor to those integration points.
Yeah, so by the way, in terms of the integrations, integration is a very broad term. Some people say, well, I just need to populate my Maximo with the asset data. That's integration. But some others are saying, well, I want it so if I change it in here, that other system gets a notification, automatically updates this kind of data, but not that kind of data. So there's more workflows, and this thing can grow into becoming quite difficult and sophisticated. But yeah, so from the very basic data exchange to the complex synchronizations, that it depends on the capacity and capabilities of the end user.
Yeah, cool. And then we got a question. I see Lizzie put a camera on, but yeah, a question around sort of the staffing and maintenance of something like this here. Once it's up and running. So we saw the GSA example there, and
every client.
Yep.
Right. So there are clients. They either outsource it to the third party companies like Augmented Construction or some other BIM consulting companies. Or they have somebody in-house, like Sydney Opera House has one BIM guy who is continuously updates the information for all of the projects that they do. Some say, no, that's not our primary expertise, so we would better outsource it to somebody. It also depends on how often you want these updates to happen. Some organizations maybe do one renovation per year. Some, like healthcare, they continuously renovate, right? So You may update it maybe weekly, maybe monthly, maybe once a year, maybe the same day. So.
Okay, cool. Okay, so there's a couple of questions around kind of people starting out in this field. So a lot of information there. You know, some of it can be quite scary. Maybe I'll pass this one to Carl. You know, if you were an end user, what were the kind of first steps you'd take if you're going on this journey? You want to start doing BIM and digital twin, quite daunting. Where would you start?
You know, I mean, I'm going to sound like a little bit of a broken record, but it's understanding what do you want to get out of it, right? You know, I'll give you a great anecdote from a project that came up literally yesterday, right? We're working on a large scale retail chain, right? We received a model for the first time. And the level of detail on some component was astounding, right? There was a coffee shop that had modeled literally to the individual packets of Splenda, right? So we ran a takeoff, right? We were doing some integration to try to quantify the model to understand how many of what exists. I can literally tell you that there were 76 packets of Splenda in the model and that there were 300 coffee stirrers in the model. At the same time, the kitchen wasn't modeled at all. Now, there's a clear definition of a use case where it's possible that that client, you know, has prefabricated this kitchen 400 times and there's no need for them because they have no desire to get any operational information out of it. But maybe that's a big pain point for them, is understanding how much sugar to buy. Now, it's a little preposterous, but I'm using that as a case study to highlight how important it is to understand what do you want to do with your digital twin, right? Do you want it? But the fundamentals, right? The fundamentals of just even understanding what does my portfolio look like? How many of X do I have? How many of Y do I have? Right? Some of those are pretty basic things that a lot of folks have a hard time answering. You know, so you know, if you're an asset manager and you have an existing portfolio, it's really understanding what do I want to get out of it, and that will in turn define. And Igor brought up a couple of great examples of like that stadium example, where that was probably an inexpensive, relatively speaking, digitization process because you didn't model all of the pipes and the ductwork and the whatever, because that was, the client didn't need that end use, right? On the far extreme end is trying to understand, say, a power plant, right, where modeling every pipe and valve and hanger has relevance in how they interact with their digital twin. So, but where do you start? It's really sitting down with somebody who's an expert to basically run you through almost like a business management style Q&A session. Well, you know, what do you want to get out of it? And depending on what you want to get out of it and what your use case is, again, whether it's existing portfolio or building new, right? Building ground up. You know, if you're a condo developer that you don't manage any of your assets after you build them, you're probably going to have a very different opinion on what your end use is than if you are building rental apartments and you maintain ownership and management of those real estate assets.
Yep, yeah, definitely. I couldn't agree more. And I think we've all seen cases of those that want to do BIM and then, you know, they don't quite know what that actually means. So I think, yeah, that's a very good point. So just following on from that, there's a question, almost, you know, good segue there, around the costs and the ROI. So maybe it's a question for both of you. So I'll start with maybe Carl on the design and construction side. Where do you see the most ROI, and then, you know, what kind of cost could people expect? And then again for Igor, you know, kind of what's the cost of kind of rolling out that digital twin for operation, and where do you see the most ROI, or what kind of ROI can people expect?
When we worked on this book with Paul Teicholz on this BIM for FM, we actually did develop the ROI calculator that was assuming various data points from the industry and calculating the return on investment kind of thing based on different applied use cases. So if, let's say, you are a Class A office owner, and you have Google and Facebook as your tenants, they don't really care that much about the utility costs. They care about the comfort of their tenant, employee, programmers, right? They can get significant savings just by improving the reaction speed of the work orders. If you work with, let's say, university client, they are struggling with having more maintenance guys hired. So for them, the cost per work order would be maybe number one priority, right? So depending on what you are looking for, if you have expensive equipment, let's say a medical research lab, equipment is so expensive, you need to be taking care of it a lot. So that may be the savings you were looking for, right? And this is just a sample, like maybe 5, 10 of those. We had, when we calculated the use cases, there were close to 20 or 30 of those. So you define that, and based on this, you define what you need to model, like risk management for the water plumbing leaks. We had a client who said, I don't have much money left because just budget has been used up. So if I need to choose, just focus on the shut-off valves or the water utilities. Electrical would be great, but we just don't have the money to model all of the electrical. It's going to cost us $100,000, and we just don't have that. So.
Great. And Carl, anything on the kind of design and construction side? Leaving it for.
Sure. I'd say that generally speaking, especially on the design and construction side, everybody loves to talk about like cost per square foot, right? On a larger scale project, I'd say, the generally speaking, the application of building information modeling is going to cost anywhere from 50 cents a square foot to $1.50 a square foot. And it could be anywhere in between. It's a little hard to draw a black, like a marker in the sand to say this is exactly it. And fundamentally, why is that? Because there's a little bit of a cost associated with all the different players. And one of the things that we're noticing right now, specifically in the New York City market, is we're reaching an inflection point with how design teams and design firms are interacting with BIM. For a very long time, BIM was considered a bolt-on, an add-on, an afterthought. Therefore, it was an additional cost always. What's happening is, as the industry is this concept that BIM is good for everybody, as painful as it can be, it really is. We're noticing more and more design firms making the jump or the switch. And what do I mean by that? That means that they're going to use BIM no matter what, because that is the new future state for that operation of that design firm. So because the 2D drawings that aren't going to go away anytime soon, really more for legal reasons than for anything else, those get pulled right out of the BIM model, right? So a lot of firms jump right into Revit as part of the construction documentation process. So in that case scenario, it's a little harder for those firms to really say, yes, really, this is my cost for BIM, right? Because they're already doing it. When you add on services like, scanning or 360-degree site photography or having a third-party QA/QC manager, again, we're talking about pennies per square foot, and they aggregate up to maybe $1, maybe $1.50. But in the grand scheme of things, that's what I was trying to point out earlier, is that this technology is not as expensive as I think most people fear. And in ROI, one of the use cases I gave earlier was a 500,000 square foot tower, where the biggest bang for the buck, to just finish answering your question, during design and construction specifically, was the QA/QC phase of the design development. And that's where, we were able to show a 1,600% ROI on the cost of that process and the impact in terms of scope certainty achieved.
1,600%. I think that's a good point to sign off on, a good ending point. So I know Igor's had to drop off, so thank him. Excellent, thank you, Carl. That was great. I'll hand over to Dan. I don't know if you've got any final closing statements, but yeah, thanks, guys.
Oh, we're good. Thanks, everybody.